This question came for 2 marks in 2005 for EC GATE. Let's see the question. The Zener diode in the regulator circuit shown in figure has Zener voltage of 5.8 volts. That is mentioned here, and a Zener knee current of 0.5 milliamperes. As always, let's take the Zener characteristics here and mention the knee current, which is 0.5 milliamperes. The maximum load current drawn from this circuit ensuring proper functioning over the input voltage range between 20 and 30 volts is. Now the condition we have to see is the maximum load current drawn. Let's say we have load here. If the load has to draw maximum, let's say IL max for a given input voltage, let's say, let's not consider the variation now. Let's say input voltage is fixed to some value. When IL is max, the amount of current that has to flow through the Zener diode should be minimum. That will be knee current. For a given input voltage, this is the condition. If input voltage is changed, for let's say 20 volts, we will have some IL max, and for 30 volts, we will have another IL max. So, which IL max will be higher? Obviously, it will be for 30 volts. As the question states, the maximum load current drawn over the entire range of 20 to 30 volts, obviously it will be at the input voltage of 30 volts. So, let us see the IL max, that is when input voltage is 30 volts, the current flowing through the current limiting resistor, which is 1 kilo ohm, will be 30 volts minus the Zener voltage here, which will be 5.8 volts. 5.8 volts divided by 1 kilo ohm. So, this will be equal to 24.2 volts divided by 1 kilo ohm. So, this will be 24.2 milliamperes. The amount of current that flows through the current limiting resistor will be 24.2 milliamperes. Now, as we discussed, if IL has to be maximum, then the Zener diode should be taking the minimum current under load variation condition. That minimum current is 0.5 milliamperes, which means if we subtract 0.5 milliamperes from this, this should be equal to IL max. This will be 23.7 milliamperes. So, the correct answer is option A, 23.7 milliamperes.